Hello, good afternoon.
Hello.
Hello.
Okay, yeah. Um, Let me share my screen. Just now I already shared, but what happened was, apparently I haven't copied the Google Meet link in order for me to join in, for me to speak because my computer microphone it's not good. So I have to use a different, yeah, different thing to display the work. So good afternoon. Again, we have a tutorial on week 8. Like I said, next week I'll be issuing the assignment. It's very, very simple. I guess you guys can do it within, one night you can complete the assignment. But of course, make sure your work is presentable. And remember, it is an assignment. So hang on. Is it assignment or did I say 2 assignment or one test, one assignment? Oh gosh, I cannot remember. 5 subjects this semester. I get confused with all the subjects. Oh, okay. It's a test class. Next week, it's a test. Oh dear, very hard for me to remember all of it. But next week, it's a test. Yeah, so that means for your test, we will be having it during our tutorial session next week. Yeah. After my tutorial, do you have class after that?
Yeah.
Yeah.
Mm-hmm. Can Yeah, so we'll be using during the tutorial session. So it will be on Tuesday. So you only have like 1 hour and a half to complete it, okay? Very short time. Um, yeah. So
So that
we'll
means
talk about that. Huh?
tutorial discussion next week.
So there's no tutorial discussion next week. It will be your midterm now.
Oh,
Unless you want to find a different day to do the tutorial, you want to do a different day to do the tests. Do you have any spare days that you can do a test? Yes.
mm, if like Friday, I
Yeah,
don't know.
can also. You want to do it on Friday, but I don't have the free time.
Oh,
Yeah. Oh, we can discuss that on Monday. Yeah, but definitely it's because I just realized it's not an assignment. The one on week 11 is the assignment. On next week is a test, apparently. Apparently, your group is the only group that has a test, one test and one assignment. The other programs, everything is assignment. That's why I always kept thinking that you guys are doing assignment. Yeah, apparently it's a test. So if it's a test, you have limited time as compared to as compared to doing assignment. Well, I'll discuss further about that on Monday. But do prepare for your uh, test number 1. I didn't even write here. Did I tell you what is it concerning with chapter 1 and chapter 1, 2, 3, 4, right? Am I correct? Just
uh,
checking whether. Hmm?
I think only discuss about the assignment only.
Come again?
The only like discuss about the assignment only.
Oh, I haven't discussed about
The
the
test yet.
test. Yeah. I'll remind me afterwards after we finish discussing about this tutorial that I asked you to do. Mm, on. I'm just checking my paper if I did write it anywhere. The only thing I've written here is test. It's on week 9, and I focus more on the assignment question rather than on the test. But your test question has been moderated and checked already, so it should be no problem. Okay. Yeah, remind me afterwards. Yeah. So let us go through this tutorial 7. There are several questions that I asked you to do. And yeah, Noel, you did ask about the last 2 questions, right? It's just a matter of equating the way we find the confidence interval, but it's just that the standard error now is with the value of error that was given in the question. But if you were are you able to get it already? If not, it is okay. We're going to discuss it later on. But just for me to know, did you manage to get the answer?
Still no.
Still.
Okay, doesn't matter. Yeah, so let us continue. Anything you would like to ask before I continue? But you can ask me any question as we go along the class. I mean, as we go through the session, do ask if you have any question. Okay. So first question is question 1, which is given to you x follows a normal. We have a mean 200 and the variance is 80, and a random sample of size 5 is taken from the distribution. Find the probability that the sample mean. The question is greater than 207, and the other one is lies between 201 and 209. Now, when we have questions such as this, it would be a good idea to start by writing uh, what information was given to us by the central limit theorem, given that x follows a normal, as what I mentioned just now, the value of the mean, and here, of course, the variance. And hence, in this case, we have a sample of size 5. Therefore, for the sample mean, it will be written in this manner. Take note, the value of the mean still remain the same, but now in terms of the standard deviation, it will be sigma squared over n, yeah, which is in the form of a variance, okay? So the 80 is actually representing a variance, 80 divided by 5, which we get a 16. It's still in the form of a variance, right? So therefore, in order to calculate the question that is asked here, we want the first one, that the sample mean is greater than 207. So this is how you should write it. Remember, we want to find the probability. So here we have the sample mean greater than 207 as given in the question. We standardize it as normal. Yeah. So here we have x bar, which is the sample mean. Now we have changed it to z, and therefore 207 we minus with the mean and divide by square root 16. So remember here, class, the value 16 here is still in the form of a variance. Therefore, we need to square root it. And when you square root 16, you get a 4. So it's 207 minus 200 divided by 4. And when you calculate it, you should get probability of z greater than 1.75. And what solution did you get from the table?
Uh,
0.0401.
Yeah, just like as the answer provided to you, yeah, 0.0401. So I hope you did check it from your table. Yeah. Any problem so far? Okay, kan? No problem in this answer. The second one is basically the same. Yeah, it's just that we have two range of values, 201 and 209. So we have to do it the same thing, but now our x is in the middle, which means 201 minus 200 divided by 4. X bar, or the sample mean, is now a z. And then you deduct this, and that would give you between 0.25 to 2.25. And hence from here, of course, you see when you draw the normal distribution to it, this value is a bigger value. So we have probability of z greater than 0.25 deduct with probability of z greater than 2.25. And that would give us a value which you need to refer from the table. I hope you get the same values. Yes or not?
Yeah.
0, yeah, you did get the same answer, yeah? So 0.4031 minus with 0.01222. So all this will give you 0.3891. So these are the answer. Very simple. How to calculate it? We've been doing normal distribution in chapter 4, and now here, based on the central limit theorem, and based on this question that is asking for the sample mean, so this is what we have to do, yeah, in order to calculate the probability of what is given. So any problem with question number 1?
No.
No problem. Okay. So moving on to question number 3. This is the next question I want you to do. And what we have here is a binomial. The n is 20. That means we have n repeated trials of 20. And the probability is 0.6. We have a random sample of size 100. Yeah. Find the probability that the sample mean is greater than 12.4 and the other one is less than 12.2. So you see, class, in this case, what you need to do first is consider what is given such that x follows a binomial with the value 20 and 0.6 for the n and the p. And hence, since this is asking for the sample mean, therefore we can say from the binomial, we can change it in terms of the sample mean, that now in order to get the mean value for x to follow a normal, we have n times p, which is 20 times 0.6, you get a 12. And of course, the variance, this is not the standard deviation yet. You just multiply whatever you got here. NP is 12 times Q, which is 0.4, and hence you get 4.8. Yeah. So what we have here, since given in the question, we have a sample of size 100, what happens here is now, therefore, we can find the sample mean such that it's now follows a normal distribution with the mean 12 and the variance value we divide by 100, which is 0.048. So do remember, this is still the value in terms of the variance. You might have written it in the form of standard deviation immediately from here because it's easier for you to do the calculation. But I find by just leaving it as variance, when you use it, you just need to remember to square root it. Yeah. So for the first question, we want probability that the sample mean is greater than 12.4. So you can see the x bar is already stated here, which means I want to find the sample mean. Standardizing it, we have 12.4 minus 12, and then divide by square root 0.048. So remember this value here, we have to square root them. Yeah. And hence, when you calculate this, you would get 1.8257, yes or no? 12.4 minus 12, and then you divide by square root of 0.048, you get 1.8257. And from these answers, yeah, of course, you can see it's more than 2 decimal places. Our table is not possible to check more than 2 decimal places. So we truncate it to become probability of Z greater than 1.83. So this is the value that you need to check from the table, right? So since it's already showing greater than, we just use the table to get the answer, which is 0.0336. Any question, anybody?
Nope.
Okay, all clear, yeah? Now the next one is less than 12.2, so it's the same thing. Calculating this, what do you get here? After you have calculated all this, it would be slightly almost the same as this value, because we only have 12.2 minus 12 divided by square root 0.048. So that would give you what value, class?
Uh, 0.91.
0.91. Yeah, logically. Yeah. So round it to become 1 minus probability of Z less than. There's something wrong here.
The symbol.
Oh, still correct. I just rounded it. But because I want to find 1 minus probability of Z less than, we do symmetrical lah. Hang on. Oh, it's already answering to the question, yeah. I got confused a bit. So hang on. Symmetrical. Yeah, that's correct answer.
Miss the symbol.
Did you get 0.8186 also?
Yeah.
Oh, because this is still minus, but basically 1 minus Z. By right, I should have another step here, but it's the same. After I really look at it, it's the same. When you check from the table, Z greater than 0.91 is still 0.1814, right? So after this step, we go to this step, then go to that. Is that okay?
Yeah.
Yeah. It's the same because from here it's already symmetrical. So I didn't bother writing it, but I did write here. So from this step to go here, then it goes to the final answer. Yeah, is it clear, everyone? Farah?
Yeah, clear.
Oh, your mic is good now. Or you're
Yeah.
using handphone, is it?
No.
Yeah.
I buy headphone yesterday.
Really? Oh dear. But then you use it for other classes also, right? Yeah.
Yes.
But your voice is very clear now. That is good. Okay, so it's clear, yeah? Do you understand how to do it? Any question? No, So
No.
I think I should proceed to the next part. Okay, good. Now the next one is having two questions, 95% and 98% confidence interval. And this is concerning a tennis ball, but the height of the bounce is the one that we measured on, and it's normally distributed, given to you standard deviation of 2, and the sample is 60, and the mean height is 140. So we need to find a 95% and 98% confidence interval for the mean height of bounds of this type of tennis ball. So here we are given n equals to 60. Yeah, that's the sample. And basically the mean, sample mean, the mean of the sample is 140 as given from this sentence here. And another information is the standard deviation is the value of 2. And of course, we look at the 95%, which is giving us a balance of 5%. That would be our alpha. So 5% as our alpha, 0.05. Now, whenever we do confidence interval, remember that you have to divide it by 2. Yeah. So dividing 0.05 divide by 2, what do you get? The value is
0.025.
Yeah. So when you divide the alpha by 2, you get 0.025, which is equivalent to 1.96. Now remember this one, you need to check from the short table, not the long table. And when you check from the short table, you'll see at the value of 0.025, it corresponds to 1.96. Okay, so we have all the information already. So we just state the 95% confidence interval. As I mentioned to you guys, this must be written. And then we write the formula. This is the formula. So remember, we have the mean plus minus. This is what I meant the error, Noel. So for question 9 and 10, we have to replace this as the error. But we'll go into that later on. I just want to mention this here. But for this calculation of the confidence interval, you just have to replace all the values as what has been listed into this formula. So we have 140 plus minus 1.96 times 2, which is the standard deviation, and divide by square root 60. Okay, so from here, when you calculate that, you should get 2 answers. The first one is minus 140 minus the value here. You get 139.49. And the other value, you plus it, you get 140.51. Is that clear?
Miss must be in 2 decimal place.
No, not necessary. If you have written it to, 4 decimal places, it's okay. But all these measurements are based on centimeter, so it doesn't really matter. You write up to 4 decimal places is recommended. You see, in Thai, we're not that specific about how many decimal places. Only for currency that relates to money, then it is required to write up to 2 decimal places only. Like it's logical thinking. But in any kind of measurement, if you write your answer up to 4 decimal places, it's still okay. You won't be deducted marks. Yeah. But here I show only 2 decimal places, can. So if you have 4 decimal places, it is still okay. Yeah.
Miss, for the bracket,
Okay.
we can use both the square bracket and the rounded bracket.
Or like this.
Yeah.
Or you mean the
Can you-
brackets down at the bottom?
I use
Is
the
it?
square.
Yeah. Okay, no problem. That is no problem. Yeah, doesn't make any difference because I know why you asked that, Noel, because the difference between the square brackets and this kind of brackets. Yeah, I know what you meant. Because some reference book, they would assume that this kind of brackets would take that 140.51 is inclusive. But when you use this some sort like a rounded brackets, this is assumed that it is less than 140.51. But in terms of confidence interval, it doesn't make any difference. Yeah, it's allowable to use.
Like the
Yeah, some reference book, like certain topics, it becomes a big focus in terms of the difference of the square brackets or it's the rounded one. Yeah, but in terms of confidence interval, it doesn't really matter. But I agree with you, some other mathematical calculation, not concerning statistics though, but like algebra, calculus and algebra, it is of a very importance there. But for this subject, no, yeah, it's okay. So the other question is 98% confidence interval. We still have n equals to 60, same information, but the only different thing is the alpha. Because now we are considering 98% confidence interval. So the balance, the alpha, is only 2, of which referring to 2%, 0.02, and of course, we have to divide it by 2, and that would only be 0.01. So if you check from the short table, I hope you did check from the short table so that you know you're familiarized to how to check from the table. 0.01 is 2.3263. And same thing, just make sure you write 98% confidence interval. This is important, okay? And, you know, put all the values in accordingly. So when you calculate this, you can see not much difference, class, isn't it? Look at the answer. When you do a 95% or 98%, there is difference, of course, but very, very minimal. And if you compare, yeah, well, see, not much difference, the value. It's just a matter of a wider range, I think, when it's 98%. That means your accuracy is much greater when you go for 98% confidence interval as compared to 95. Yeah, you see, this one is smaller space, smaller range, I mean, whereas this one is much more bigger. Well, slightly bigger if you talk about the amount that is stated. Yeah, but you can see 95%, it's much more, how do you say, smaller range as compared to the 98%, which is a wider range. Yeah. Right. Any question? Any question? Anybody?
No.
Okay. So if no question, then we go on to the next question. Question number 9. So in this question, a psychologist, he has developed, he or she, I don't know, a new test of spatial perception. Oh, she wants to estimate the mean score achieved by male pilots. How many people must she test if she wants the sample mean to be in error? You see the word error here, by no more than 2 points, and given to you 95% confidence. And an earlier study, yeah, is the standard deviation is 21.2. So basically, you can read from here that she wants to estimate the mean score. Yeah. And also, how many people, you see, this should be the keyword for you. How many people, that means what is the number of sample? that you must have, and in order to meet to the sample mean, that it is not more than 2.0 points. So in order to solve this, we list out all the information given. It's 95% confidence. Yeah. So our alpha is 5%, which is equivalent to 0.05. Yeah. And this 2 is our error. So normally we use R to indicate the error. And of course, the standard deviation given as 21.2. Now, what we do, it doesn't involve a lot of complicated calculation, but you'll see that we're just equating the confidence interval formula into what information given. Yeah. Of course, when we consider the alpha as 0.05, we have to divide it by 2, which means now, again, when you divide 0.05 divided by 2, you get 0.025. And that gives you 1.96 after you check from the short table. So what do we do here? N with 95% confidence, when R is given as the value of 2, is given by, you notice that? This is the original formula for the confidence interval, of which equal to the mean plus minus 2. So you must check out this sentence here. How many people must she test if she wants the sample mean to be in error by no more than 2 points? So that is why we have the sample mean, yeah, no more by 2 points. Could you hold on for a while, please, yeah?
Okay.
Okay, sorry about that. You see, we are in the middle of preparing the course file for NQA. So I thought, like, maybe because it's an unknown number, I thought it's from KL, from main campus, calling me about my files if I have missed any forms and stuff. And then when I answered, you know who the person is? Have you received a call from a man called James, and he's asking donation for an orphanage in Ipoh?
I
No.
think my mom.
Huh? Did you get any calls like that? None? The thing is, I'm surprised how he got my number. I haven't blocked his number yet. But he keeps on calling and he messages me every day.
Yeah, many with phone calls nowadays.
Can? So I thought it was from KL. That's why I answered. So I will block the number in the future. And I just cut him off. I said I'm having class. So sorry about that. It's just that I was concerned because I was getting calls from message from his telling about there was one missing files for my course file. So sorry, yeah. So continue. Where was I? Yeah, I was talking about, from this sentence, kan, she wants the mean sample to be in error by no more than 2 points. So that's why we have the sample mean, and this is representing the error. Yeah, so now all this representing the value 2, of which, let me get my pen, cancel this out. Both sides exist, right? So you can see that now we have this equal. Well, of course, this would cancel out also. Do you agree? And since I want to find how many people That means I want to find the value of n, since the z, what is the value of the z? We already highlight that. The z is 1.96, so we can replace 1.96 here. The standard deviation is 21.2. The only value we need to find now is the n. So you see here, let me get back my pen. We have sigma over square root n. First of all, we have 2 divided by 1.96. I hope you understand my handwriting, okay? And then if you cross multiply, you would have 2 square root n equals to 1.96 sigma. Well, sigma, we know also the value is 21.2, which I haven't changed. So what I have is n equals to 1.96 multiply with the sigma, which is the standard deviation, 21.2, and then divide by 2. Now, because this is a square root, I can simply remove all the square roots, yeah, by just power 2 it. So same thing here, I power 2. So will that give me the value of n? Yes?
Oh yeah.
Yeah. So just to show you, this is what you should get eventually. So you notice the similarities. It's just that here it hasn't changed the value of 1.96 times with 21.2 divided by 2 and all power 2. So that is how we get, that's how we get from this to there. And this to show you how we get to here. And after we work out all this and replacing all the values just like what I've written here, yeah, just like what has been written there. And of course, when you calculate that, you should get the value of n equals to about 431.64, and since the value 0.6, yeah, it's more than 5, we can approximate it to 432 people. And that would be your n. Is that clear?
Miss, the error, did we encounter what show in the slides yesterday?
No. Okay. In my slide, I didn't show exactly the working for this, but I think I mentioned it when I was explaining about these, that this part is known as the maximum error. I mentioned it in class, but I didn't focus on it thoroughly. This is basically referring to the error. And whenever you have questions such as this, where it states what is the value of the error, that means the R is referring to all this value. Oops. I did mention though that the sigma over square root n is what we call as the, I think I did mention error. Forgive me if I didn't mention, and perhaps that's the reason why you can't.
You always round up the number.
I always round up the value. You're talking about down here, is it, Calvin?
Yeah, is it round? Does you always round up, or do you just?
Well, yeah, because this is concerning with people, so it's a bit weird if you leave people as in 431.64. So
You
we
round
round
down?
it. Yeah,
Do you round
advice.
down?
Or round up or round down, is it? Yeah, we round up for this case because it's 0.6. If let's say I got 431.2, I would take 431 lah.
Okay.
Yeah. Okay. So any other question? But it is understood it's the error is referring to that. Did you spend so much time on trying to solve this? Is it Noel? Oh dear. So sorry about that. It's a bit like a challenging kind of question. Yeah. It's different from the normal question that you have been exposed to in the slides. So I was trying to see whether you get the idea out of it.
Do
So
you
I
have
might,
do you always have to write the given label? Do you have to label all the value?
It would be
Alpha equals blah blah blah. and
yeah.
then
It's a
R
good
equals
habit
blah,
to
blah, blah.
write. Of course, this one it's up to you to write it or not. But it's well, this one I see in the marking scheme, just to share with everyone, the marking scheme of the exam, they do assign, like when I do the marking for this question, they do assign like 1 mark here. So it is recommended to write. Actually, there's 2 marks here, like 1 mark on getting this, because this one you need to check from the table, right? And then listing all this, the question would give 1 mark. But if let's say student didn't do this, then I would, manually go and check, like, did the student when they write the formula, did the student write the value correctly? So if you did, then you get the marks lah, even though you didn't list out here. But it would make my work easier if you already listed it. But at the same time, class, I've also seen some students, they already write all the values up here correctly, but when they write it in the formula, it gone salah. They wrote the wrong value pula. So do take note of that. It does happen. I mean, no harm for you to spend time in writing this down, because by that you'll be sure which value is it referring to. Yeah. Any other question? Okay, just to share with everyone as well, this kind of question very seldom come out in the final exam. I think because examiner don't want to stress student out so much, because this kind of question, what have been observed, only a few can answer. So to tell or share with everyone, this kind of question concerning with the error very seldom come out in the exam. Yeah. Assignment I cannot promise. Yeah. In fact, I don't remember your assignment question already. I've done that quite a while, so I can't remember which one I covered.
Do we do both assignment and the test and the midterm next week, or is the assignment week 11?
Different time. Yeah, the first assignment, the test is next week, and then your second, the assignment is on week 11. Yeah, not both together. No. Even though the assignment, the assignment you should be able to do already.
Is it solo?
Huh?
Is it individual?
Yeah, it is individual. For math subjects, normally it's individual. Did I give you group work last time? No, man, it's individual.
Yeah.
Yeah, maths is normally individual. Except for the diploma students, yeah, like one subject it's called calculus and algebra. That one assignment is doing individual, the other assignment is group work, but they have to include one recording video of them doing the assignment together as a group. So yeah, and the video is not awarded any grades, but luckily the students, they do it also. Good students, they comply, they just do the recording, but it's not hard to do. Yeah. So any other question concerning this? You think you can do the question 10 then. Yes?
Yeah, should be okay.
Yeah, should be the same, right? So here is clear. Farah, you also okay with this one, can Farah?
Yeah.
Okay, good. So now, question number 10. Yeah. Error is 0.1 seconds. So it's the same question but slightly different with different values. You have standard deviation and 99% confidence. So I'm going to show a bit faster this one. We'll go as we work on it, of course. So you see all the information stated with the values alpha divided by 2. Check out from the short table, you get 2.5758. And from here, standard error, the error of 0.1, you just equate it, same thing like just now, yeah? And of course, solving the n. I've already shown the other example just now how we can transform it to become in this manner. So you just have to put all the values here, and when you calculate this should give you 165.8686, of which I take 166 observations. And that's the answer. Any question?
No.
Oh, yeah.
So that's it. That was what we covered yesterday. Yesterday, did we do the hypothesis testing? We started on hypothesis testing, right? We did. I can check on the recorded video, but I can't remember now. My memory is very bad. I think I lack of sleep because we have been doing the filing, and I'm trying to finish my filing. It's done, but then yesterday I received another instruction from Miss Tang, so I have to do it. It's a bit tiring. Well, yeah. So from all the tutorial question for yesterday's lesson, I hope you understand how to do the estimation and also the confidence intervals. These are the two things, yeah. Important areas which
now
you should
this next
expect
part I
in
think
your
we'll do it
assignment.
next week. I
And
think
of
it's
course
a
in
good
your
point
final
to stop
exam.
because
And
it's already 10:56.
I don't know. Did we finish chapter
Unless there's
5?
any other question you would like to ask, but I'm
No, we finished chapter 5, but we haven't started chapter 6, is it?
Yeah.
Yeah.
From
So,
the,
huh?
from the recording, the last what slide is about the estimation of parameters.
Oh, so but confidence interval we already covered, kan? So that would be hypothesis testing. I really have to check your assignment, your test paper class. So can we have a break? We'll come back at 1 o'clock, and then there's nothing else I want to cover basically, but I want to talk about your assessment, your coursework, especially your test for next week, because
so
we'll have our class on Monday, and then on Tuesday will be your test. So let's have a break for 10 minutes. I'll see you guys in a short while. Okay?
Okay.
Okay. Hello. Are you all back?
Oh,
Yeah.
Mm-hmm. I've checked your the status of your what do you call it? Coursework. Yeah, you have two. I think I've informed you guys about it already. You have one test and one assignment. Yeah, the assignment will be given on week 11. That I'm correct on that, and there are 7 questions for the assignment. Chapter 2, 3, 4, and 5. That is in week 11. But the coming one, which is next week, it will be a test. Yeah. And you have question 1 until question 6. 6 questions to do. What I can tell you concerning with the test, there are 6 questions. No graph will be required of you to do, but I would admit that you have to really understand chapter 2, 3, and 4. Yeah, make sure you understand all the chapters that we have done, especially how can you get full mark lah, because there are certain things that you need to show, like when you calculate the mean, what must be shown. So all the slides that I've shared with you, I mean the recorded video, go through them so that you'll be able to answer accordingly, so that you can get full mark in terms of the marking scheme.
Still need to draw graph in the graph paper.
No need. I think I purposely decided not to have any graph paper requirement because it's still under MCO, and our class we never had a face-to-face, so my decision is not to have graph paper. But say like chapter 3, there is a drawing also, draw a probability tree. So in that chapter 3, you might be asked to draw a probability tree, so make sure you know that. It only covers chapter 1 to chapter 4, but mainly the question, because chapter 1 was more like introduction and it's more on the graph, and since there is no graph required, so you just focus on chapter 2, 3, 4. Yeah, that means descriptive statistics. That means you must know your mean, your median, and your mode, together with the standard deviation. How do you calculate all of that? I think in chapter 2 also we did what we call as the quartiles. First quartile, third quartile, the quartile division. So make sure you know all of that. Areas on interpreting the answer that you get. Yeah, how do you interpret the mean, the mode, the median? Yeah, that should be your focus. And also do remember that when you're doing descriptive statistics, there are 2 types of data. One is group data and the other is ungrouped data. And the formula to solve ungrouped data is different from the formula for group data, right? So you have to look at the data, what type is it given, because in the question it will not state this is ungrouped data, this is group data. So you must know the difference. Yeah. Yeah, basically that is from chapter 2. What else do we have in chapter 2? Basically all that the one that I've mentioned. And then when you go to chapter 3, focus on, all the laws of the probability. Make sure you know how to do it. Probability tree, Venn diagram, and also the contingency table. Do you remember that? How do you answer when it involves with a conditional probability? Is there a case of a Bayes theorem that you need to apply in order to answer the question? So that is what you should focus in chapter 3. And in chapter 4 is more on, we did the binomial, the Poisson, and the normal, right? So just these three methods: identify the parameters, how do you calculate them, how do you know that that question is, what kind of distribution is it? Is it normal, is it Poisson, or is it binomial? um, it is a test, so it's not a bring home kind of thing. There is a limit for you to do. So the plan is to give you guys 1.5 hours during the tutorial itself to complete the work. Yeah. But my concern is, after my, like today, it's exactly a week from today. After my class, the next class is what time?
Three.
Huh?
3.
3 o'clock. Okay, so if that's the case, yeah, just nice lah. I will we'll start the test at 1 p.m. and by 3 p.m. you must submit. Is it too rushing for you? I could make it at 12:45, and then you pass, the due time to pass up is at 2:45. Is that too much?
Oh, means
You think it's, huh? What did you say, Noel? I didn't get you.
submit before 3, like that.
Before 3. How about 12:45 to 2:45? That would be 2 hours lah kan? Okay or not?
Yeah, 2 hours.
Yeah, I think that would be sufficient. So that would be the duration of time that I would give, because it is stated in the, I checked already, yeah. It is stated as a test, so there is a limit. I'm giving you extra hours actually. Extra time, not extra hours. So you have 2 hours to complete 6 short question, but you have to write a lot, class. I mean, the question is not difficult. There's nothing tricky about it, but because chapter 1 to chapter 4 is quite a lot of calculation involved, so you need to be fast. So make sure you know your topics well. Yeah, go through the what do you call that? The recorded video if there's any parts you don't understand. And of course you can ask me. But sometimes I talk nonsense done in my recorded video. So sorry about that. Yeah. Any other question, class?
Oh, this one for the test
Any?
one.
Huh?
The test
Come
one,
again?
1 to 4. The test. Chapter 1 to 4.
Yeah. It's from chapter 1 to chapter 4. But chapter 1, because chapter 1 is more on the histogram and the OGIF, right? So it's not touch much on that. It would be more on chapter 2 to chapter 4. Yeah. I think that's all. I gave you so much information already. You must write your answer on a paper, A4 paper or foolscap paper. Like normal lah, you have to take a picture of it or you scan it. If you have a scanner at home, you scan it. If you have a printer, now a printer normally comes together with a scanner. So you scan it or you use your handphone to scan it and save it in one PDF file, just like what we did in the previous semester, and then upload in the Google Classroom before the time allocated. If notebook like got line, like if note, what do you mean, Farah? If notebook like got line, oh, can no, Farah. Yes, easier for you to write your answer, right? Yeah, you can, but not the small book lah. The preferably like A4 size lah. If notebook can, when you scan it also, I mean, I still will mark it, but preferably A4 paper or foolscap paper lah. Because you see, your group, it's only 3 of you, and all of you, your work will be submitted as a sample to the MQA later on when they come and visit next time. So that's why we need students to write it on A4 paper, because your work will be reviewed by the MQA much later now. But it will be kept, and normally MQA wants like three or more samples, 3 samples lah, and you guys now 3 samples. So all of your work is submitted. Oh yeah, and make sure when you scan it, can the color, I mean, it's not blurry, because you know when you're doing maths, statistics, it's about numbers a lot. So if it's blurry, very hard for me. I have to spend so much time thinking, is that a 4 or an A? So make sure it's clear when you scan it. That's the thing that we have to adjust to during MCO. But hopefully next semester no more like this, can we go back to the campus and all is safe. Yeah, just follow SOP, should be okay. Yeah. Any other question, Paul?
So far, no.
Huh?
So
No,
far,
no question. So far, no question, is it? Yeah,
yeah.
so just be ready. Be ready for the test. It will be on Tuesday, so I will use the tutorial session. So be ready. You have 1 week to prepare. 3 chapters only. Yeah, but go through the, go through the lecture notes or your notes that you have prepared. I mean, you have copied to your notes. Go through them, and if you understand what we have covered so far, you should do okay. Yeah. So be prepared lah. It's different from discrete mathematics. Yeah, discrete mathematics was the question is quite short, and the answer also quite short. Not like in probability and statistics. Your answer, you have to do tables, you have to do calculation. You've seen how the working is so far. The question is like an essay. Yeah. So be ready, okay?
Okay.
Yes? Yeah.
Okay.
So So if there is no more question, I have nothing else to say already. Just be ready for the test next week, for the tutorial session.
Okay.
Okay? So Calvin, any question from you?
No.
Okay. So if none, then I think that's all for today. We end quite early. Yeah, a bit early, about 15 minutes early. So I think it's still okay lah to end 15 minutes earlier than required. Unless you guys have any other question, you can stay and ask. I'll be here until 2:30.
Okay, Miss.
But you guys can leave. Thank you very much. That's all for today.
Okay, Miss. Thank you.
Thank you, miss.
Thank you. Bye bye. Thank you.